All right, so here it says, consider the function q of x is equal to x times x minus 3 times x plus 5. And it's asking what are the zeros. So we saw yesterday how we find the zeros, especially when it's already in factored form. So I'm going to set each of these equal to 0. X equals 0, x minus 3 equals 0, and x plus 5 equals 0. This is already x equals 0. There's no extra work to be done here. These are both one-step equations. So I'm just going to add 3 to both sides and subtract 5 from both sides. Why am I adding 3? Because I have to do the inverse operation. And whatever you do to one side, you do to the other. So I get x equals 3. Why am I subtracting 5? Because you have to do the inverse or opposite operation. And subtraction is the opposite of addition. And whatever you do to one side, you have to do to the other. We also talked about yesterday how if it's in the parentheses and the coefficient on the x is a 1, like it is in these, it's not 1. I don't want to keep saying greater than 1 because it could be negative, which is less than 1. So if the coefficient is not 1, you do have to do some extra steps. But since we just have 1 here, I could automatically just say, all right, well, this would be switched, and that's 3. This would be switched, and that's negative 5. And this x is just 0. So you could quickly get them like that as well. So there's 2 different ways. So those are the zeros. And if we wanted to write these as coordinates, we would write 0, 0, 3, 0, and 5. Negative 5, 0. Cool. So the next one says, use reasoning like what you apply with products of 2 linear factors to write a rule for q of x in standard polynomial form. Record your steps in your work so someone else could check your reasoning. What that is basically saying, it's asking us to use the reasoning, basically what we've already learned before, when we're doing the product. So product, remember, means multiplication. Well, really, it's what comes out of multiplication. But so it's giving us an indicator that we need to multiply 2 factors. So like binomial. So basically, in a nutshell, it's asking us to multiply x times x minus 3 times x plus 5. It's asking us to do this multiplication. And we know how to do this for the most part. We're used to doing x minus 3 times x plus 5. So right now, I'm just going to ignore the x right here on the outside. And I'm going to multiply these using double distribution on the left side, and on the right side, I'm going to do box method. So over here, I have x times x plus 5 minus 3 times x plus 5. So this is the distributive method. So I get x times x gives me x squared. 5 times x gives me 5x. Negative 3 times x gives me negative 3x. And negative 3 times 5 gives me negative 15. And then we know at this point we need to combine our like terms, and we would get x squared plus 2x minus 15. And I'm just going to do box method over here for those who prefer box method. So here I get x squared, then 3 times x gives me 3x, x times 5 gives me 5x. Was one of these negative? Yep, I meant to write negative here. Negative. Yeah, so it's negative 3x, sorry. And then negative 3 times 5 is negative 15. And remember, in box method, we get this cool feature that the diagonal is always our like terms, unless we, made a mistake. So now we have x squared plus, what on earth is that? X squared plus 2x minus 15. So regardless of what method you use, we get the same thing. But remember, we weren't asked to multiply 2 binomials. That would have been too easy. We have this x on the outside. So now I'm going to not ignore this anymore. But either way, I always want to start with the multiplication of the 2 binomials first. And now it's actually a lot easier than you might think. Now, regardless of which method I'm using, if I use distribution from the start or if I use box method, I'm just going to distribute in x. And remember, distribution means whatever's on the outside of the parenthesis is going to multiply by every term on the inside of the parenthesis. Whatever's on the outside of the parenthesis is going to multiply by every term on the inside of the parenthesis. And so x times x squared, remember, this is 1x, x squared is 2x's. So if I multiply x times x squared, that's 3x's, so x to the third power. We could also just say, well, we know that this has an exponent of 1, and we know at this point that we should just add the exponents, and that's how we get the new exponent. Same here. We know this is an exponent of 1, so x times 2x is going to give us 2x squared. And finally, this was a constant, but if we multiply it by an x, it becomes negative 15x. And the same thing would happen on the right. So this is the answer. So make sure that when you are given problems like this, you always start multiplying with the two binomials first, and then multiply in the monomial. You can multiply the monomial in, but I find what a lot of people do is they multiply this and distribute it into these two binomials. So do not do that. Just start with a binomial so that you do not make a mistake. All right, and so this is called q of x. So let me label that q of x. And now it says identify the degree of q of x. You know at this point that the degree is the highest exponent. So the degree here is 3. We see that it's 3 right there. It says, how could you have predicted that how could you have predicted that property of the polynomial before any algebraic multiplication? How could you have predicted that? Well, let's just look here. I have an x here and an x here, which I knew were going to be multiplied. And if I multiply them, that gives me x squared. I also have an x here on the outside trying to multiply in, and that would give me x cubed. So I could have predicted that the degree would have been 3 had I just counted the x's that I had from the beginning. 1, 2, 3. My degree is 3. Matches. So that is how I could have predicted it. So make sure you go back over this and try to do number 2, practice problem.